Okie dokie. Shout out to Claire for sending me this problem. I figured it'd be a good one to work out for everybody, so let's jump into it. We are evaluating this integral, and we want to use U-substitution. So we want to first identify our U. It should be inside parentheses typically, and it should be acted upon by some outer function. And so in this case, we will pick the square root of 8x plus 6 as our U. So the U will be the entire square root of 8x plus 6. So we want to find the derivative of this. So it'll require some chain rule. It might help to rewrite this U as 8x plus 6 all to the 1/2 power. So rewriting the square root as a power of 1/2. This allows us to take the derivative of the outside layer, the 1/2 power, using power rule. So we want to bring this 1/2 out. We want to leave the inside layer the same, so 8x plus 6, and then we subtract 1 from the original exponent to give us negative 1/2. So that was the derivative of the outside layer, the 1/2 power. So now what we want to do is multiply by the derivative of the inside layer. The inside layer is 8x plus 6, and its derivative is just 8. So altogether, if we tack on a dx, we have our du times dx. So what I might do is multiply the 1/2 here and this 8. 1/2 times 8 gives us a nice 4. And I might go ahead and rewrite this term that's raised to the negative 1/2. I'm going to write it in the denominator, raised to the positive 1/2. And now we want to solve for dx. So we're going to get dx by itself by multiplying by the reciprocal of this fraction. So I'm just going to throw 8x plus 6 to the 1/2 over 4. And then this is times du. Now, one more thing I might do before I make substitutions is rewrite 8x plus 6 to the 1/2 as the square root of 8x plus 6. So basically rewrite it back in the form of the square root. So we have u and we have dx. Following the procedure we usually use, I'm going to rewrite this integral as 2 cosine, and then inside the cosine is our u. Excuse me. We can leave the denominator the exact same. And then, actually, I guess we could plug in u in place of it, but let's just leave it like this for now. This is how we usually do it. And then what we'll do is plug in the dx. So the substitution for dx is here. We have the square root of 8x plus 6 over 4, and then I'll just throw in the du here. So the reason I did not want to call this u is because if we did, then these two would not cancel out in the same way that they were supposed to. So I would just, do it the same way we usually do. We just plug in the u wherever u is supposed to go, and we usually just plug in this stuff wherever dx goes. And then we can cancel out all the x terms like we just did, and then we can gather our constant terms and, simplify those. So 2 over 4 gives us 1/2, and we are left with just the integral of cosine of u du. So that entire original integral has been simplified to 1/2 cosine of u. So now we just take the antiderivative of cosine of u. The antiderivative of positive cosine is positive sine of u with the 1/2 on the outside. And then if we plug back in the u, it was square root of 8x plus 6. Tack on a c, and this should be our final answer. And this looks like option F, I believe. The 1/2 probably tells us everything we need to know. So I'm going to go with F as our answer. There's the entire problem. Thanks again to Claire for sending me this problem. This is a really good one to practice. And so, thanks again. Hope this helps. If you have any questions on any other problems, please let me know.